Okay, so what I want to show you now is for differentiation when you use the product or the quotient rule. So with the product rule, it's the format is given to you in the, or the formula is given to you in the formula sheet at the end of your N4 paper. And you have this y equals ux times vx. I'm going to just put it in color just to help make things a little bit simpler. So y equals ux, and then they tell you if y equals ux, then dy over dx, which is the same as, so dy over dx. If you ever see y dash, that just means the same thing. It's just a notation thing. So dy over dx or y dash, it just means derivative. And then they say it'll be ux, so the pink thing, times the v dash x. So that means ux just written as what you had it as. And then find the derivative of the second thing you're multiplying by, which is vx, plus then the second thing will be derive the first thing, u dash, times by vx. So the second function remains the same in the second part. Okay, so how it's easier to look at this in terms of an example. So let's say that you have y equals, and they give you, let's say, x squared times, say, sine x. Okay, so this is, you get given a function here, or an equation where you've got two things, x squared and a sine x. Well, let's just say that we had y equals x squared. Well, we know the derivative of y of x squared is 2x, right? We take one of the exponent and we times the front by the exponent. And then the derivative of sine x, when you look in your formula sheet, so if I was to just reveal that, you can just see sine x is cos x, right? So that's in the formula sheet already there. So we know that if our y dash had been, our y had been sine x, then your y dash would be cos x. So these things are very easy to differentiate by themselves, but now you've got them as a product of each other. How does that change? Well, all you do is you simply just look at this formula. And now I'm going to highlight what's what. So we see our x squared is our pink. Right, so x squared is our pink. And our sine x is the second thing we times it by, is our blue. And so then we just put in our value. So we see x squared is pink. So the sine x is the blue bit, and the derivative of the blue bit is here. And then our x squared is the pink part. Okay, so now we can see how they relate, and then that's why I say get highlighters for the exam. It does help sometimes to highlight things so that you can recognize what's what. So now if they want dy over dx, or y dash, same thing, we can say dy over dx is equal to, and then it's the pink thing, which is our x squared. So we just put in our x squared. Then it's the derivative of the blue thing, right? Because it's v dash. So the derivative of the blue thing is this thing, is cos x. Plus derivative of the, now it's the derivative of the first thing, which is our 2x. And then the second thing, the vx remains unchanged. So it's just vx, right, which is sine x. Okay, so if you weren't sure what happened there, you can watch again. But basically, what do we have? This was our ux. This was our u dash x. This was our vx. And this was our v dash x. Okay, so that's the product rule. Fairly simple once you get to know it. It's just about recognizing when to use it. So if you were given, say, cos x, I'm not going to do it because I want to go into the quotient, but if you had cos x times sin x, you could actually use the product rule here, where you make this your ux and this your vx, and then you just follow the formula. Okay. So when you get one thing times another thing, I also want to say, if you get the derivative of cos x, and you know the derivative of cos x is minus sin x, technically you are using a product rule because this is a 1 here. And so what you are saying is, okay, 1 times cos x, or the derivative of cos x is sin x, and you leave the 1 alone. But then the derivative of 1, you know, is 0. So you get 0 times, and then you leave the cos x alone. And so the 0 times cos x ends up going away. So the product rule is in everything you do, but it's not needed unless you have two kind of complicated things times by each other. So like an x squared or an x cubed times a tan x or something like that. All right, so now let's look at the second thing that the rule, which is the quotient rule. So again, I'm going to do colors here to make it a little more simple. So we have y equals, and then our ux, again, we're going to draw in pink. And our vx, we're going to draw in blue. And so we just plug in the formula, right? So it'll be y dash equals, so our vx, so the thing in blue, so the thing at the bottom, times the derivative of the top thing, as we're saying u dash, minus the ux, so then the top unchanged, multiplied by the vx, the bottom, sorry, the derivative v dash x. Okay, you can see that. But you can see it over here anyway. Here's the formula. Okay, so over the bottom squared. So with these, it's simply about plugging in to the formula. Okay, so let's look at an example. Tell you what, I'm going to just, because I've already done these, I'm going to just say it was x squared over sin x. So say they give you, what is the derivative of x squared over sin x? So again, we've got something divided by something. We could derive x squared, we can derive sin x, but we don't know how to do this thing unless we use the quotient rule. So our top is our pink. So let's highlight what we have. So our top is our pink, which is x squared. And our bottom is our sin x, which is our vx. And I've already done what the derivative is of each of them. So now all we do is simply plug in. So we put in our vx, the blue, which is our sin x, right? So we say sin x times by, and then it's u dash x, which is the derivative of our x squared, which is 2x. Minus, now we leave the top unchanged, so that's x squared. Then the second bit is our v dash x. Okay, it didn't come out so well when I wrote it, but then I'm highlighting it there in blue as well over here. So v dash x, we check this derivative of sin x, which is cos x. So this is simply just subbing in. So all it really is a substitution. And then after that, we may be able to simplify a little bit. Divided by. Well, the bottom is just, oh, I didn't put a squared here. The bottom is squared. So what we do is we just take the bottom and we square it. Well, the square, when you square sine x, it just becomes sine squared x. So that's nice. I can just say sine squared x. Okay, and that's it. That's done. Okay, so that's our product rule and our quotient rule. I have more than 10 minutes, so I'm going to do the chain rule now. So chain rule is something a little bit different. Okay, so let's look at the chain rule. Okay, so the chain rule sort of says if you have f and a function g of x inside the function, the derivative is f of g of x I'm going to call it the inside-outside rule and put the, so I'm going to write the rule like this. So the derivative space. So if you have f of g of x, then the derivative is equal to down here. Then f dash of g of x, so the derivative of this whole thing is equal to inside. What you do is you derive the inside, g dash of x. So the formula is quite confusing. And then you times by f dash g of x. So let's put it on. This will become a lot more simpler when I actually do it. Okay, so they call this the inside-outside rule, and it's used for something like this. If you have the square root of, say, let's make it tricky. Let's put a sine x in here. Okay, so what this is if you ever get this, anything to the square root is the same as to the power of a half. So what this actually is saying is sine x to the half. Okay, now how does this resemble the chain rule that we're looking at? Well, the chain rule shows a light blue with a pink inside. So I'm going to highlight what would be considered the light blue would be this. And then the pink would be this here. And so what we do is we find the derivative of the inside. So this is called the inside-outside rule. So we find the derivative of the sine x. The derivative of sine x is cos x. Then what we do is we times that by the derivative of the outside. So imagine that we were trying to derive this light blue thing. Well, we say we times the exponent by the front. And then we have, we leave the sine x alone. And then we, when we take one off this, we get minus a half. Okay, so that's how that would look. And so we would get, we would end up getting cos x over sine the square root of sine x. This, when it goes to the bottom, becomes to the positive a half. So I could tidy it up and say that would be cos over 2 sine x. I'll do a slightly less complicated one. Something like this. So this is something more like what you would see. I should have started with this one. Let's say you have x squared plus 1 cubed. Now I ask you to find the derivative of this. So if they say f is equal to that, what is f dash? Well, what we do is our chain rule is we're looking for an outside and an inside. So our outside is this. Okay, and our inside is this. And the reason I'm calling it the inside-outside rule is because I must, if I imagine that I've got an outside and an inside, I'm going to derive the inside and then derive the outside. Okay, so if we think inside-outside, what do I do? Find the derivative of the inside. The derivative of the inside, x squared, is 2 times x, so that's 2x. Okay, so you see I've done this bit here. Then what I do is I find the derivative of the outside. So I say, well, it'll be 3 times the front, which is 3. And then I do leave the inside alone. Okay, so we see, and then I take 1 of the 3. So that's the 2. That's 2. Okay, so if I highlight what I'm talking about in terms of the rule, it's that bit there. Okay, now focus more on the product rule and the quotient rule, because I don't see the chain rule in the formula sheet. So you may not even need to do it, but I seem to remember seeing a chain rule question. So I just want to go over it just in case it comes up. And then we leave the inside alone, the g of x alone, right? So the g of x, we leave the x squared plus 1 alone. And that's it. And so 2 times 3 is 6. That becomes 6x, x squared plus 1 to the power of 2. And that's our derivative. Okay, so we went through the product rule, the beginning, and then the quotient rule. And then I just, because we had a bit of time, I popped on the chain rule just in case. All right, so watch that again, and then we'll do some examples to see how that might work in an exam question.